Hello and welcome to this video on the IUPAC nomenclature of aldehydes. So let's first of all understand what aldehydes are. Now so far we have done functional groups like alkenes, alkynes, alcohols and ethers. But aldehydes are a special type of compounds which have the functional group of C double bond OH. And on this side you have the chain attached. As you can notice that this carbon, since this functional group contains a carbon, it is very important to include this carbon in the parent chain, which means such functional groups are called chain terminating functional groups. They are chain terminating functional groups because they occur at the beginning or end of the chain, because one side is occupied by H. Unlike an alkene which had a carbon double bond carbon, and you could still have carbons beyond that. So the double bond could be at the end, could be here, or it could be somewhere in the middle also. Alkyne is similar. Alcohol is also similar. In fact, alcohol doesn't even contain a carbon atom. So the alcohol could be either here or the alcohol could be here. It doesn't matter. Whereas this kind of a functional group that contains a carbon always occurs at the end or the beginning of a chain. So these are called chain terminating functional groups. Now let us understand how we are going to name these. Now if you have, here the naming depends upon the number of aldehyde groups that you have in a molecule. So first of all, we will curtail ourselves to a situation where you have one aldehyde group. So let us say you have something like this, and when you take the parent chain, if you have one aldehyde group, the parent chain must always use the carbon of the CHO. This must always be included. And if no other functional group exists which may have a higher priority compared to CHO, and that is what we're going to see, then this carbon is always numbered as 1 and the others would be numbered accordingly. So if one aldehyde is present, that carbon is always numbered as 1. Now the situation changes a little bit when you have two functional groups of aldehydes. Obviously one would be at the beginning, the other would be at the end, because these are the ends of the chain. They will always be at the end of the chain. So how do we do this? Here, if you have one aldehyde group, the name changes from alkane. We remove the E and we put Al. It becomes alkanal. You put Al there. If you have two of them, now remember, the reason we remove this E is because the Al starts with a vowel. So if it is two of them, we call it a dial. So in which case we can retain the E and we say it is alkane dial. You don't have to specify the position numbers because the position numbers are always going to be 1 and the last. And remember, when you name the alkane must include the carbons of both the aldehydes. This aldehyde carbon and this aldehyde carbon you must use in naming. So this is the simplest way of naming simple aldehydes. So the name of an unbranched acyclic mono or dialdehyde is formed by adding the suffix al, and that is for a monoaldehyde, with the elision of a terminal E, or a dial for a dialdehyde, in which case you retain the E, to the name of the hydrocarbon. The carbonyl group takes precedence over alkyl groups in halogen substituents as well as double bonds in the numbering of the parent chain. So it must be given the first priority. Now what could be the simplest of aldehyde? Well, the aldehyde anyway has to have this. So what could be the smallest molecular weight aldehyde? It can only be when this bond is also attached to H. And we call this as methanol, derived from methane. Remove the E of the methane and put Al, methanol. It is also known as formaldehyde, which is its common name, and formaldehyde is also accepted as the IUPAC name. What would be the next homologue of this? Well, you put a CH2 on H, it becomes CH3 and you get this. Again remember, it has got two carbons, ethane, remove the E, put Al, ethanol. Common name is acetaldehyde, and we also retain this common name in the IUPAC system. Try naming this one. Pause the video, name it, play it back and check. Now in this case, we have to select the longest carbon chain containing the aldehyde and numbering from the aldehyde. So this is always 1. And as you can see, if this is 1 and this is 2, one of the CH3s have to be 3. There are only 3 carbon chain here. So this is a propane aldehyde, so it's propanol. And there is a methylene too, so it's 2-methylpropanol. Note that we don't have to write 1-ul because it is always assumed to be the 1 anyway. Now what would happen if in the case of formaldehyde I remove this H and put a benzene ring? pH, a phenyl group. So when I put a phenyl group here, this becomes benzenal. It is the aldehyde of benzene. So benzene is written like this. We remove the E, put Al, it becomes benzenal. And the common name is benzaldehyde, which is also accepted in the IUPAC system. So we have benzenal or benzaldehyde for this particular molecule. Now what happens when you have double bonds? What happens when you have triple bonds? Well, the same logic applies. Alkene, remove the E, alkenyl. So when both double bonds and carbonyl groups are present, the N suffix follows the parent chain directly and the L suffix follows the N suffix. Notice the E is left off N instead of ene, that we have already seen. And of course you have to number the ene but not the L. Now the location of the double bond is indicated by the numbers, and the L suffix follows the N suffix directly. It is not necessary to remove mention the number of the carbonyl group. Automatically the first carbonyl carbon will always retain the first position. This, remember, in the case of aldehyde and ketone, this particular carbon is called the carbonyl carbon. It is carbonyl. Anyway, so let's check out a couple of examples. How do you name this? Pause, name, play. So while the parent chain must include the carbonyl carbon, and then if you have double bonds, it must have maximum number of multiple bonds. So obviously the parent chain is this, and we'll always give number 1 to the carbon of the aldehyde. So this is 1, 2, 3, 4. So which alkene is this? It is but3-ene. And since it's an aldehyde, it's but3-enyl. And you have the prefix 3-methyl. 3-methyl but3-enyl. How would you name this one? Remember the two aldehyde groups? So it's a diel. And alkane diel Now in this case, the alkane will also include the carbon of the two aldehyde carbons. So numbering goes like this, and we get 11 carbons. So it is undecanediol. Name this one. Remember, the parent chain must include the aldehyde. Pause, name and play. So this carbon is included and you must get maximum number of multiple bonds. There's only one way of doing that, that is this. So this is the parent chain. So 1, 2, 3, 4, 5, 6, 7. You have a vinyl substituent on 3. And what is the parent? The parent should be 7 carbons. So it is hept 4n6-inyl. And the prefix is 3-vinyl. So 3-vinyl hept 4n6-inyl. Well, try this one. Now here the numbering has to go from the right side because we need to give the double bond the lowest number. So 1, 2, 3, 4, 5, 6. So it is hex 2-ene-diol. We retain this E because it is diol D. Okay. Try this one. Pause, name and play. Obviously, I must include the two aldehyde carbons. There's only one way. This is the way. And this is the substituent. So let's number the parent first. We must give the lowest number to the double bond now. So it's starting from the right side. There's 7 carbons. Let's number the substituent. So what is the substituent called? The substituent is called buta-1,3-dinyl. And this is in position 5. And what is the parent called? The parent is called hept 2-n-diol. So this is going to look like this. 5-buta-1,3-dinyl hept 2-ene-diol. Now let's progress forward. Now let's understand what will happen if more than 2 aldehyde groups are present. Now this is going to be a little troublesome. Troublesome because if there are 2 aldehyde groups, we can always look for a chain in which one occurs in the beginning and one occurs at the end. If there are 2 aldehyde groups present, now irrespective of whatever branching you may have, wherever you may have, if you have 2 aldehyde groups, then there is always this method of looking for the parent chain containing one at the beginning, one at the end. The problem comes up when there are 3 aldehyde groups. Now it is not possible that all the 3 would occur at this beginning and the end, because beginning in the end is only 2. So where would the third one go? So when you have the third aldehyde groups, the naming becomes a little different, and it depends on where they are located. So the naming of an acyclic aldehyde having more than 2 aldehyde groups is different from that having 1 or 2 aldehyde groups, as these are chain terminating groups. So they cannot occur, 3 of them cannot occur in the same plane, in the same chain, in the beginning and end. Because in beginning you can have 1, in the end you can have 1, so where will the third go? There is a way out in this. The first thing is, and there are various situations in this, we look for all the situations. First situation that we'll consider is that I have a parent chain, I have a chain in which I have the 3 aldehyde groups directly attached. if there is a chain in which the aldehyde groups are directly attached, then what we are going to do is we are not going to include the carbon of the aldehyde in the naming. We will only look at the chain on which the 3 CHO groups are attached. We will name this as alkane, where the alkane part consists of these 3 carbon atoms, and we call the 3 CHO as tricarbaldehyde. So the 3 CHOs become tricarbaldehyde and this part becomes alkane, and you have to indicate the position numbers. If they are here right now, of course it is 1, 2, 3, but if they occur at different positions, you have to use those position numbers, P, Q, R, tricarbaldehyde, and so on. So this is the first situation. The first situation is the 3 CHO groups are attached directly to a chain. In such cases, the aldehyde group is treated as a substituent and the compound named as alkane, PQR, etc., polycarbaldehyde, which could be a di, tri, of course it can't be a di, it can only be a tri or a tetra, and so on, where the alkane part does not include the carbon of the aldehyde group. So remember, there is no di here, because if it is di, you simply say dial. If it is tri and more than tri, only then we have this particular situation. So let us name one and then you will be able to understand this. Let's name this one. Pause. And after pausing, please remember, try to find a chain of carbon atoms on which the CHOs are directly attached. Look at this chain. Carbon, carbon, carbon. This is CHO, this is CHO, this is CHO. So basically there are 3 carbon atoms. In each of the 3 carbon atoms, I have a CHO attached. This is the same thing as we saw earlier. So how do we name this? Very simple. Forget the CHOs, just number the chain. The chain must start with the carbon having this CHO group. This is numbered as 1, 2, 3. 3 carbons means propane. So it's going to be propane 1, 2, 3 tricarbaldehyde. Let's try one more. This will help us clarify this thing better. First of all, where are the CHOs located? Pause the video, try it on your own first and then look back here. There is a CHO here. There is a CHO here. There is a CHO here. And think of a chain on which the CHOs are directly attached. Look at this one. Look at this chain. A CHO is attached to this carbon. A CHO is attached to this carbon directly. A CHO is attached to this carbon directly. So the 3 CHO groups are attached directly to a chain. So we only number the chain. And remember, we must give 1 to that carbon which contains one of those CHOs or the least value to that particular CHO. Since this is the parent chain and I have CHO attached to the very end carbon, automatically it will be numbered as 1. So how am I going to name this? What is the parent called? The parent is called non 4N 2 ein 1 5 7 tricarbaldehyde. Because it's 9, so it is non. 4 you have ene, so have N. 2 you have ein, so have ein. I write the E because the next one is not starting with a vowel. It is 1, 5 and 7 tricarbaldehyde. It is starting with a T. So I retain the E of the alkyne. This is the parent, and now you put the prefixes ethyl, methyl and stuff like that. So this is going to be 4 ethyl 6 methyl, non 4N 2 ine 157 tricarbaldehyde. So this is how you name when you have more than 2 chain terminating functional groups. It's valid for all of those which are chain terminating functional groups. Now comes the second possibility, that I have 3 aldehydes, but in any given chain only 2 of them are directly attached. One of them is attached through a carbon. Say for example, let's say I have a CHO here. Let's say I have a CHO here. But the third CHO is attached like this. Now I can never have a chain in which all the CHOs are directly attached. For example, if you consider this chain, only these 2 CHOs are attached directly. This CHO is attached through a carbon. If I take this, then this CHO is not directly attached. So if you have a situation like that, so let me draw it properly. Suppose you have a situation, let me make it a little simpler in the beginning. Suppose you have something like this. So in any given chain only 2 CHOs exist, then choose that chain which is the longest, or the one which contains maximum number of multiple bonds if there are multiple bonds. In this particular case we contain this chain. Now this chain is considered the parent chain. So this is a dial, because the CHO is not directly attached. So now what are we going to call this one? We are going to number it first 1, 2, and the CHO prefix, whenever CHO is used as a prefix, it's called oxo. So it is 2 oxo, because the CHO is in 2 oxo ethyl, because there are 2 carbon atoms. One is this carbon atom, the other is the carbon atom of the CHO. So it is basically N oxo alkyl, where the alkyl includes the carbon of the CHO. Now one might wonder, why do we write 2 oxo ethyl? Why can't we simply write oxo ethyl? Because if it is aldehyde, it is automatically going to be in the position 2. But remember, suppose if in the same situation, if suppose I had a ketone here, then this is also named as oxo. If it is used as a prefix, it's named as oxo. This will be 1 oxoethyl. So whether it is an aldehyde or a ketone, the prefix becomes oxo. Only thing is the numbering would change. Let's see. If in a trialdehyde system, one of the aldehyde group is not directly attached to the parent chain, then it will be treated as an oxoalkyl group. Alkyl includes the carbon of the aldehyde, and the molecule treated as a derivative of a diol system. So we need to check out an example to be able to understand this. So let's look at this one. Now try and figure out, is there any chain in which all the 3 aldehydes are directly attached? One of them is this, but here this is not directly attached. One could be this, but this is not directly attached. and one could be this, but this is not directly attached. So none of the three can never come in a single chain. So we choose the chain which has maximum number of multiple bonds, and if that being same, maximum number of carbon atoms. So I can go 1, 2, 3, 4, 5, 6, 7. Either I go 6, 7 here or 6, 7 on top, it doesn't matter. And the numbering has to be done because it's a dial system, so the numbering has to start at aldehyde and end at aldehyde. And I start from the top because I want to give the double bond the lowest value. So it is heptane dial. But now since there is an ene also, so it is hept 3 ene dial. That's the parent. Hept 3 ene dial. And now you can use all the prefixes you want. So now what are the substituents attached? There is this fellow and then there is this fellow. Now if you remember, this is already, we have named this 2-oxoethyl, 1, 2. If you number this 1, 2, 3, 4. Now remember, this is an alkylidene system. We saw that in alkenes. So here we simply forget the double bond here. To represent this double bond, it will be IDENE, idene. And now just name this as an alkyl or alkynyl group. It is going to be but 4 inyl, and now include IDENE to represent this double bond. So what do we have here? We have something like this. So it is 2, because on 2 you have but 2 inylidene 5 oxoethyl hept 3 ene dial. Now comes one last part. Now imagine there are 4 aldehyde systems, and whatever is applicable for 4 is applicable for more than 4 also. So let's look at 4 aldehyde systems in which 3 of them occur in the parent, 3 of them occur in a single chain, 1 of them does not. So in that case, say for example, let me draw a simple situation. CHO directly attached, CHO directly attached, CHO directly attached, and there is one CHO not directly attached. So look for that chain that contains maximum number of CHOs directly attached. And if there are more than one such chains, maximum number of carbon atoms, or maximum number of multiple bonds, and then maximum number of carbon atoms, and so on. Then what you do, this is named as oxoethyl or oxoalkyl, and these will be tricarbaldehyde. So which means in the parent alkane you don't use these carbons. The numbering will have to start like this and progress, not including these carbon atoms. So if in a tetraaldehyde system, one of the aldehyde group is not directly attached to the parent chain, then it will be treated as an oxoalkyl group. Alkyl includes the carbon of the aldehyde, and the parent name becomes alkene PQR tricarbaldehyde, where the alkane part does not include the carbons of the aldehyde. So whenever you use tricarbaldehyde, the carbon of the aldehyde is not used. Let's take an example and check. Well, look for a chain in which maximum number of CHOs are directly attached, and I can very well see this. Can you see that? And here you have this CHO directly attached, you have this CHO directly attached, you have this CHO directly attached, but one of the CHOs is not directly attached because it is attached through a carbon here. So what do? Well, we take this as the parent. This is the parent. number it such that CHO carbon gets the lowest value. So we have to number it from the left side. And we are not going to number the carbon of the aldehyde, remember? It's a tricarbaldehyde system. So only the carbon attached to the CHO. Now what do we do? Well, we have one prefix. There will be only one prefix. There is only one substituent here. That is 2-oxoethyl. 1, 2. So let's number that also. It's 2-oxoethyl. And it is attached to the second carbon of the parent. So it is 2-oxoethyl. But what is the parent now? The parent is the two double bonds. It's nona 4 3 5 diene 7 ine. And where are the carbaldehydes? 1 3 5 tricarbaldehyde. Check out the name. 2,2-oxoethyl nona 3,5-diene 7-ine 1,3,5 tricarbaldehyde. So that is the way this particular molecule has been named. Now this is not going to be that easy to get in the first instance itself. You probably would need to see this video several times to be able to understand this. Go through that. If you have any issues, please write your comments, write your doubts, whatever issues you have, and I'll try to reply to these as much or as soon as I can. And I hope this helps you in understanding the naming of different types of aldehyde systems. I hope that by looking into these videos, you have more clarity in naming them. And again, as I said, any issues, any questions, any doubts you have, please drop it in the comment section. Thanks for watching.